So our learning goal, we are starting lesson 6.5 now, and you've already done the one assignment. And when you're multiplying a monomial times another monomial, and maybe there are even, I feel like maybe a time or two where there are even 3 monomials involved in your multiplication. So monomials being polynomials that have what? What are monomials? What does that mean? When we say we're multiplying a monomial times another monomial, and maybe even times another monomial.
Single term.
The single term is a polynomial where there's no, so what operation can't be going on in it? Addition or subtraction, right? It's just all multiplication, one term. But then when one of those gets added or subtracted with another one, now we've got more than one term. Okay, so what we're going to do today, now we're going to expand on that, and we're going to multiply a polynomial of 2 or more terms, so 2 terms or more, by a monomial. Okay, so we're going to have to do distributive property, basically. We're going to have a multiplier that has to be multiplied over addition or subtraction, and of course we'll change our subtraction to add the opposite. So it'll be doing distributive properties. So I want you to put at the top of this notebook page that we are doing lesson 6.5. Okay, the noisemaker needs to stop, thank you. And lesson 6.5 notes. And we're going to write our learning goal, okay? So, whether you're copying it from me or you're looking over at the board over there, I can multiply a polynomial of 2 terms or more as soon as we hear that there are 2 terms, or even more than 2 terms, we know that within that polynomial there's some addition or subtraction going on, or maybe a combination of both. And the polynomial is going to be multiplied by another polynomial, but a specific polynomial, a monomial one. Okay? So, I think the key words in here: multiply, polynomial, by monomial. Okay, those are the really key words. I want you to do the same thing in your learning. I want you to underline, box, circle, something. I can multiply a polynomial, so we're going to multiply a polynomial by a monomial. So we're actually going to do check it out problems. So we're going to put that this is where these came from, just so that you know that, you know what, if you need more help, you could look to the example problem that's there. So I want you to put that on page, I'll write it down for you. I'm not going to make you open your book, but I want you to put that on page 423. Check it out. That's where these are going to come from. So they are the practice problems that go with the example above it. And we're going to do 2A. Okay, so you had to study example problem 1 for today to help you with the homework. Okay, so you've already done the practice on the example 1 type. So now we're going to practice the example 2 type. So we have 2 times, in parentheses, the polynomial 4x squared plus x plus 3. Now remember when we started this chapter, once we got past the exponents part, once we started talking about polynomials, I told you that we were working with polynomials before we even were calling them that, weren't we? So is 2 a polynomial?
Yes.
Yeah. What kind of a polynomial is it?
It's a monomial.
It's a monomial, and what special type of?
Constant.
A constant monomial. So we're multiplying a monomial times, what's our other polynomial called? What's its name?
A quadratic trinomial.
A quadratic. Why it's quadratic? Why is it called quadratic base?
Well,
Well, Cody, I gotta get other people's, brains over with their mouths too. Thank you, though. You are so participatory. Faith, why is it called quadratic, this other one? Why does Cody claim it's a quadratic trinomial? Why is it quadratic? Because it's the degree. It's degree what? 2. Degree 2. And why is Cody calling it a trinomial, Devante?
Because it has all 3 terms.
It has 3 terms. So we're taking a monomial times a quadratic trinomial in this case, and we're just going to do our distributive property, aren't we? So we're going to have 3 multiplications, and we're going to show them. 2 times 4x squared. And I like to do this just to kind of show, because you know what, they kind of start getting lost when the polynomials that we're going to multiply, when we keep multiplying, these polynomials are going to get longer. There aren't even going to be monomials involved in it anymore. So it's kind of nice just to learn how to keep them organized. So every one of those terms of that second polynomial has to be multiplied by the 2 that's out front. We should have 3 multiplications. Okay, well there's no rearranging needed to be done in that first one, is there?
No.
What can be multiplied?
The 2 and
The 2 and the
4.
4? So this one becomes what?
2 times 4.
Which is what?
8x to the second power.
8x squared. The x's don't have anything else to be multiplied by, do they? The second term, Clarion, what's that one going to become? The second term, what's that going to become? 2x. Trust me, I'm not asking any trick questions. I just need you to alert, that's all. Calvin, what's the last term going to become?
6.
6. Okay, do we have any like terms there? No? Do we have this in standard form?
Yes.
So we're going to say we're done. Okay. Our answer is the polynomial 8x squared plus 2x plus 6. Okay, let's do 2b now, which you don't have your book open, so I'll write it down for you. We have 3ab, that happens to be our monomial involved in this problem, and it's going to get multiplied times the polynomial 5a squared plus b. Okay. I want to know, can we classify, can we give a name to either of those polynomials involved in this multiplication problem?
Yes.
Can we name 5a or 3ab?
Yes.
Okay, what's it saying then, Cody?
Constant trinomial.
A constant trinomial?
A constant monomial.
Constant monomial, okay? Because it's, if it's a constant, it's degree what?
0. Or the degree 0.
0, okay? So we're saying this is a degree 0? Okay. Oh, something I think we're forgetting.
And we already have one, and B has one.
So they each have their own degree of 1,
So it would be a linear monomial.
but what? Cody?
Wouldn't it be, okay, can I change my answer?
Sure.
Wouldn't it be a linear trinomial because there's 3 terms? Because the A, the B, and the 3
Are called terms?
are, well,
They're part of an addition problem or
no,
a
so
subtraction
it'd be
problem?
a linear monomial still. Because they're not being added, they're being,
So they're not terms. What are they called when they're parts of a multiplication problem? This is, you know what, this is important that you guys seriously know the answers to these things, and I take the time to stop and ask you. They're important. You need to know them. I don't just do it because I like to talk. So what are the parts of a multiplication problem called? They're not called
Product.
terms. No, the parts. Huh?
product is,
Factors.
you know,
Factors. So the factors of 3ab are 3a and b. Those are the factors. But I don't think we ever really had to focus too much on this. We cannot classify, we cannot name a polynomial that has more than one variable in it. This has a's and it has b's, so we can't give it a name. It's just a monomial, okay? That's all. Okay, but then our other one, can we name that one?
yes.
5a squared plus b. Cody?
It's a quadratic binomial.
Quadratic because it's what?
Or degree 2,
And binomial because what?
2 terms.
But it has only one variable in it? No, it's got a's and it's got b's. Okay, so my point I'm trying to make right now is we gotta keep this up here. We can only name polynomials when they have what? Just one variable, either all a's, all b's, all z's, all x's, all d's, whatever they are. They just can only have one variable involved in them. Okay, now back to let's get this multiplied. Okay, we have two multiplications to do. We have 3ab, that has to be multiplied times 5a squared. Write these down carefully because you know what? Just one little piece missing makes the whole thing wrong. I had to take some points away from people who could not transfer their answers from their work page to their quiz. And I took them away because I took the time before you took the quiz to say, take the time to look it over, check it over. Okay, and now the other multiplication is 3ab times b, right?
Yep.
Okay, like we did for today, if there's, you know, stuff that needs to be rearranged in there, we're going to rearrange it. So what would the rearranging look like for this one? What would the rearranging look like? Okay, Cody.
3a, or 3 times a,
3 times 5. And then should that be boxed? Or
Nope, we're going to just keep it all together.
times a to the second?
Can we take care of this a first?
Times A.
I kind of like to just kind of, you know, like, it, but we can do it. If you want a to the second to be first and a to be after it, it's okay. And then what?
Times a.
Times b. Okay, so basically what I want us to do is I want us just to rename that one. And if you want to then underline the things that can actually be multiplied within it, feel free. Yes?
Wouldn't we put 2 B's?
Why?
Or- Because there's 2 B's. Like
Where do you
there's
see two b's?
Oh, and that's where.
Just in that one.
We're talking about-
Just in that multiplication. We're not going to get too carried away here. We want to just stay within one multiplication.
I thought you
Okay?
were talking about
Yeah, here we're actually taking a monomial times a monomial, so now we're doing what we did yesterday. And now we're gonna, how are we gonna rearrange this one? 3 times,
a times b times b.
yeah, and that one really kind of was already in a good order, wasn't it? Okay, what's this, what does this multiplication become? What's the product of the first one? 15,
a to the third.
a to the third, b, 3 times 5, 15, a to the first times a to the second, add their exponents, and then b doesn't have anything to be multiplied by. And what's the other one become?
3a b to the second.
3a, and the b is to the second power. Right? Are they like terms?
Yes.
Are a cubes b's the same
No.
as ab squared?
No.
You look at the variable part and they're going to match exactly. Are they identical?
No.
No, so we would say this is our final answer because it cannot be simplified. We don't have anything to combine. Yes, Mikhail.
Do you want us to add the 15 and the 3 at all? Or wait, no, because they're both separate, aren't they?
Yeah, we can't. If they were like terms, that's what we would do.
Okay.
But since they don't have matching variable parts, we can't. Okay? Any other questions before we try another one? Okay, write down 2c now. We have 5r squared s squared. You know, remember that first of all, the 5 should be bigger than the variables because 5's and s's can get mixed up. You can't tell one from the other sometimes, but the 5 should be bigger than the s. And then we're going to have it times r minus 3. And again, that s should be smaller than that 3. So it would be the first thing we would do in this problem. Tori? What would be the first thing we would do? No. We say to ourselves, oh yes, 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 I see, Julia. Change it to add the opposite. I see subtraction. I know that, you know what? She's going to say I have to change that to add the opposite. And I am insisting that you do because these multiplications are going to get a lot more complicated as we go along. Okay? So yes, I am insisting that you change this to add the opposite. Okay, now we're ready to do our multiplying. This whole thing here out front is getting distributed. It's a lot bigger than those other two pieces, isn't it? So 5r to the second power, s to the second power is going to get multiplied times that r. And then we bring down the plus sign that we have. And we say now that 5r squared s squared has to be multiplied times the negative 3s. There's our other multiplication. You know what, please, just, some of you are probably like, I don't really want to put anything around my multiplications, but trust me, it's going to be a lot easier to keep track of things. Okay, this is just like yesterday, what we did for yesterday now. In our homework for today, I mean. We have a monomial times a monomial, so we just rearrange. So we're going to let the constant be first. We'll let the r's come next because r is before s in the alphabet. And the s squareds will be last. All we're doing is rearranging. Rearrange. Constants get to be first, that's a negative 3. R's get to be next, the S's are last. Okay, multiply it out, clean up your answer, and let's see if we all get the same thing. What do you think? Like my answer? Am I done? Really?
No. Cool. Yes. Yes, you are done.
No. Gotta change.
No, it was at the opposite, and I cleaned it up.
You have to check if they're like terms.
Okay, are they like terms? Are r squared s cubed the same as r cubed s squared? In other words, you look at right here, this is where you look. You look at these parts right here, and are they exactly alike? No. They both have r's, they both have s's, they have some 2's, they have some 3's, but are they in the right location? No. So our final answer is going to be the 5r cubed s squared minus 15r squared s cubed. Don't get caught combining things that can't be combined, but then don't forget to combine things when they can be combined. So, we're going to do one more problem. Are you ready for it? We're going to do one that's like the one in your homework. I don't want, they didn't have a checked out problem like this to do. So what we're really going to do is a problem from, let's just put that it's, I'll leave this here in case somebody still needs it a little bit. We're going to do a problem from their homework page, which is page 427. We're going to do number 12. Okay? So here's how it is given to you in the book. It is 5m squared n to the third power times m n squared. And then they have times a binomial, or a two-term. It's not really, it's kind of like a binomial. We can call it a binomial, but we can't give it another name. Or m minus n. Okay, what do you think?
I think we should do what's outside the or add the opposite on these other parentheses.
Okay, so that would be one of the things that we would do is we would say we're going to take the, but I want to show something else that we could also do within this step. What's going on here between the 5, the m squared, n cubed? What's going on between them? What operation? That's just multiplication too, isn't it? Just like they show a multiplication there. Okay, so really what's happening here is we have a multiplication. That's a monomial. It's being multiplied times another monomial, which then the multiplication is going to be of the 4m minus n, a binomial. So what we can do is we can just, is there multiplication going on between this m and this n squared also?
Yes.
So we can just insert a whole bunch of multiplication symbols to show that we just have one long multiplication there in front. And then inside our parentheses, we will change this to add the opposite. And in fact, if we want, we can stick a 1 in there, can't we? I think that threw some people off on one of your problems for today. A negative sign in front of a variable really means negative 1 of those, right? Cody?
Should we rearrange the 5 times m to the second power times n to the third in like 5m to the second power times m times n to the third times n to the second? Could you do that too?
Okay, tell me how you want to rearrange it.
5 times m to the second times m times n to the third times n to the second power.
Okay, so can we do that right there? Is there any addition or subtraction going on in there? Is there any, just look at this part right here. This is where he's working. Is there any addition or subtraction going on in that? No. When you have multiplication, can you multiply in any order you want?
Yes.
Yeah, so that's what we're doing. We're rearranging, making our groups, aren't we? Okay. So basically, this is the way I would attack this problem. Exactly. I would take all of that multiplication out front, because there's no addition or sign or anything going on in between here. I'm just going to take all that multiplication going on out front, and I'm going to get that taken care of, and then we still have this to deal with. We're not going to forget about it. Okay? We're not going to forget about that. It's still there. But we're going to find out what this is first. Okay? Because what you can't do is you can't just let this 4m become part of this group and then say, you know what, minus n, I'll take care of you at the very end. That we can't do. But we can take care of all that multiplication out front. So what does this become? 5?
M to the third times n to the fourth.
Times n to the 5th. Okay, so what we had out front here became this monomial, 5m cubed n to the 5th. And that is what's going to get multiplied times the 4m plus negative. We're going to take that times that binomial. So now it looks like the problems we've just been doing. But we had to get that kind of like all put together. So now we're ready to do our distributive property, where we'll say 5m cubed n to the 5th. There's lots of writing that goes on. You've got to make sure you write them carefully. Times 4m. That's our first multiplication. The first arm. Plus. Now we have to take that 5m cubed n to the 5th times negative 1n. There's our second multiplication. Okay, now we'll do rearranging within our multiplications, right? What's next? So we'll take the 5 times the 4. What comes next? M's. Yep, the M's come next because M comes before N in the alphabet. So times M cubed times M times N squared. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. There's our first one rearranged. And our other one rearranged. Okay, and why it was really handy to put that 1 in there right here is because now we understand that's a negative 1 instead of the variable being negative. Okay? So now we can treat that as a constant. We have 5 times negative 1 times m cubed times n to the 5th times n. There.
whoopsie, there's our second multiplication. 5, -1, m cubed, no other m's, n to the 5th, n.
Double check. Just don't be afraid to check and double check your work, okay?
What's the first multiplications product?
20 m to the 4th, n to the 5th.
Why is it m to the 4th, Cody?
Because 3 times m is just saying 3, or m to the 3rd power plus 1. Well, I think
This is really a 1 here, isn't it? So we have to add 3 plus 1, okay? Someone other than Cody, he needs to rest his vocal cords. Noah, I don't think I've heard much from you for the other one.
-5 times m to the 3rd times n to the 6th.
Okay. Let's look at them and see if they're like terms. Are they like terms?
No.
No. M for n to the 4th, n to the 5th, n to the 3rd, n to the 6th. Now, so they're not like terms, so the best I can do is just clean it up, right? Just clean it up. Whew. Monomials times monomials might have been just a little bit easier, right? But we're still in the end really multiplying monomials times monomials when we're doing our distributive property. Okay, anybody have any questions, any part that you need to clarify? Okay, let's get busy on homework then.